Hi, my name is Kate Rakelli, and I'll be talking about my ongoing research project in the field of computer vision under the advisement of Professor Alyosha Efros at UC Berkeley. We've collected a large data set of historical yearbook photos and are using them to explore how fashion has changed over time. We collected the data ourselves from public library websites and the Internet Archive this past summer. We've collected data from 27 states and 244 schools for a total of 949 yearbooks. After all pre-processing and filtering, we are left with a total of 37,921 individual portraits. Here are some examples of the yearbook pages. On the left is a page from the 1930s, and on the right a page from the 2000s. We have data from 1910 to 2013 and from all across the United States. Here's a chart showing the temporal and spatial distribution of our data. On the x-axis, we have the year, and on the y-axis, the number of faces we collected from that year. The colors represent the 7 different regional zones in the United States. For example, the Pacific region is pink, and the Midwestern region is yellow. While we do not have a good coverage prior to about 1930, and the geographic distribution is not very even, our temporal coverage is good. I built a pre-processing pipeline to crop, filter, and align the images. The first stage involved cropping the portraits from the yearbook pages. As we were interested in fashion and hairstyle, we wanted to retain the entire portrait, not just the face. Using OpenCV, I wrote a rectangle detector that worked in tandem with a standard face detector to crop the images while mostly ignoring candid shots and baby photos that are often sprinkled throughout yearbooks. The final stages of the pre-processing pipeline involved discarding faces that were looking more than 10 degrees to either side. Then I aligned the faces by their eyes and performed grayscale normalization. Finally, I trained a simple SVM classifier to separate the male and female faces. Here's a test example of the first stage of that process, rectangle detection, where the yellow boxes indicate discovered rectangles. To get a sense of our data, I generated the average image from each decade for males and females. On the left are the men, and on the right are the women. The first row is the 1900s, 10s, 20s, and 30s, and so on all the way to the 2010s in the lower right. We can see demographic changes in these averages, to some extent due to the geographic biases in our data, but also due to actual changing demographics of the US. And in the men, we can see clearly that suit and tie was standard wear for many decades before morphing into more casual clothes. In the women, we can see that wearing the hair up was a predominant style for many decades before the popularity of long, straightened hair in the 2000s. Here is the heart of the research. I am curious about what stylistic features in hair and clothing make a decade look like that decade. For example, we're familiar with the 60s bob, but what other trends make the 60s unique? To answer this question, I set out to learn a feature embedding of the data that encodes similarity in fashion and hairstyle. Our semi-supervised method is to fine-tune a convolutional neural net with the task of predicting the date of the photo, and then use the features extracted from this model as our embedding. Our reasoning is that since fashion correlates with the year, the network will learn fashion differences in order to correctly predict the date of the photo. Started with the task of classifying the decade of the photo, fine-tuned a model provided by the Café neural net framework, and achieved good results with about 60% accuracy in predicting the decade. Here is the confusion matrix for the classification task, and its diagonal nature indicates that when the classifier is wrong, it's not off by much. So when it misclassifies the 60s photo as from the 50s, it's not far off. There's an interesting confusion between the 1990s and the 1920s, perhaps explained by the resurging popularity of very short hairstyles in the 90s. Here's an interesting visualization of the best and worst predictions for each decade. So the top row shows the correct classifications made with the highest confidence. We can see the iconic 60s bouffant, the long straight hair indicative of the 70s, the short crimped hairstyle of the 30s. The bottom row shows the images classified incorrectly with the highest confidence, with the wrong guess along the bottom of the image. In a sense, these are the girls most out of their time. We can see a 70s girl with a beehive understandably misclassified as the 60s, and a very curly-haired 90s girl misclassified as from the 80s. So we've done a good job dating the photos, but how good is the feature embedding we've learned? Using the embedding learned by the network, I clustered each decade with k equals 4 and computed the average of each cluster. These cluster averages reveal modes in each decade. For example, both the long straight hair and the African American afro are present in the cluster averages for the 1970s. Unfortunately, the image statistics, background of the photo, and artifacts created by the preprocessing are a problem as the network latches onto these clues to predict the decade of a photo, rather than being forced to rely solely on the fashion and hairstyle. We are currently working on a few different ideas to mitigate these problems. So why does this work matter? I see this work as part of a new field of computational visual history. There are a lot of historical images, too many for humans to be able to study with their own eyes to discern broad trends. With computer vision, we can create ways for historians to study images en masse, to discover unknown trends that are perhaps too subtle for the human eye, or only appear when examining a large collection of images. I'd like to acknowledge my advisor, Professor Alyosha Efros, my collaborator and mentor, Shiri Ginozar, and collaborator, Sarah Sachs. Thanks for listening.